Hello viewers, I am Maitli. Today we are going to see 12th Cbse Maths Relation and Function exercise 1.2 question number 7. Let's see the question. In each of the following cases, state whether the function is one-to-one or onto, one-to-one onto or bijective. So if it is one-to-one and onto, it will be a bijective function. Justify your answer. Yeah, the first subdivision they are given. F is equal to R to R defined by f of x is equal to 3 minus 4x. F is relation from R to R, F is a function from real numbers to a real numbers defined by f of x is equal to 3 minus 4x. It is in the equation form. So let me go with the proof. Here for 1 to 1, let f of x1 is equal to f of x2. I am going to take this to be f of x1 is equal to x2. We know that for x1, just substitute the value of x1 in the place of x. So 3 minus 4x1 is equal to 3 minus 4x2. Yeah, 3 get cancelled, minus get cancelled, 4 get cancelled. It will become x1 is equal to x2. So if x1 is equal to x2, then we can say that therefore f is one-to-one function. Other than this, if anything comes, it is not a one-to-one function. It should be x1 is equal to the x2. If it is x1 is equal to x2, then we can say that it is a one-to-one function. Now for onto, let me take y is equal to, let y is equal to f of x. Now we know that f of x is nothing but 3 minus 4x. Bring x is equal to, so I am going to bring minus 4x to this side and y to this side. Now bring 4 to the denominator because it is in multiply, it comes as a divide. Now for y, if we substitute any value of y, any real numbers of y will get a value for x. So there is no any condition here. The denominator is 4, so it can be in fraction because it is a real number. It can be of any number. For any answer of x, there is no condition for y. We can substitute any value of y in the place of any real number in the place of y. We will get a value for x because it is a real number. It can be a fraction. It can be in root. It can be of anything. So we can say that for all values of y, x is equal to 3 minus y by 4 exists. So any value we will get our x. If there is if we get our x, then we can say that therefore range will be equal to, the range is nothing but the substitution of y. Here the y will be your range. The range, it can be any real numbers. Here the codomain is also, it's given that the codomain is a real number. R to R means here it is domain and this will be your range. Sorry, a codomain. Your codomain is R. According to this, we can say that codomain is equal to range therefore f is onto function. They have asked for bijective. Therefore f is bijective because it satisfies both the one-to-one and the onto function. So we can say it to be a bijective function. That's all with the first subdivision. Move on to the second subdivision. In the second subdivision, it is given as f is from R to R. F of x is equal to 1 plus x square. Yeah. Now let me take f of x1 is equal to f of x2. Yeah, 1 plus x square equal to x1 square equal to 1 plus x2 square. Now this 2 get cancelled. x1 square equal to x2 square. Bring everything to one side. x1 square minus x2 square equal to 0. Now x1 minus x2 into x1 plus x2 equal to 0. Here the condition here is x1 is equal to x2. Here x1 is equal to minus x2. Here we are getting two answers. That is it will be equal to minus 1, or it will be equal, sorry, minus value, or the same way it will be equal to plus value. Here this condition, if I substitute x1 to be 1, x2 to be 1, it can be 1 or it can be minus 2. So it is not equal here. In the two condition, if we see, it can be, if we take x1 equal to x2, directly we can say that it is 1-to-1 function. But here we can see there is also a value for negative value also is there. So it can't be a 1-to-1. Let me check with the number. I am going to take x to be minus 1. If it is minus 1, it becomes 1 plus minus 1 the whole square, which is nothing but 1 plus 1, which is equal to 2. And f of 1 equal to 1 plus 1 square, which is equal to 2. Here, according to this, we know that if I substitute minus 1, I get my same value 2. If I substitute 1, I get the same value 2. That means it is not a 1-to-1 function. Therefore, f is not an 1-to-1 function. Because it has 2 as a same image 2. Minus 1 and 1 as a same image 2. So it is not a 1-to-1. Let me check for onto function. For an onto function, let y is equal to f of x. Here y is equal to 1 plus f of x. We know that it is 1 plus x square. So I am substituting x square. Bring number to this side. Y minus 1 equal to x square. So x will be equal to root of y minus 1. Here. Now if you check what value we can substitute for y, we can substitute we can substitute any value greater than 0, because if it is greater than 0, it should be greater than 1, greater than or equal to 1 also we can take. So here the condition is y is greater than or equal to 1. Only then you will get in the root the real numbers. In the root, it should not be a negative number. Here in this place, if we substitute any number, if we substitute 0 instead of the place of y, we get the value to be root of minus 1. If we substitute minus 1, it will be of root of minus 2, which is not a real number. The condition here is real number to a real number. The function here is a real number to a real number. So the y cannot be less than 1. It should be greater than or equal to 1 is our condition. So x exists only if y is greater than or equal to 1. That means the range lies between where? The range, your final answer lies between 1 to infinity, because it is greater than or equal to 1 means it lies between 1 to infinite. So your codomain here is real numbers. So according to this, we know that codomain is not equal to our range. So it is not a 1-to-1 function. Sorry, onto function. So we have proved the second subdivision. It is not a 1-to-1 as well as it is not a onto function. That's all with the sum. Thank you.